Teste, som. Som. Teste. Testando. Testando. Som. Tem um atraso, não? Tem um atraso. Teste, som. Teste, som. Fala assim. Teste, som. Som, testando. Teste, som. Dá um like. Curte aí o nosso vídeo. Tá massa? Segue aí, clica no sininho. Teste, som, testando. Teste, som. Teste, som. Testando, teste, som. Testando, som. Teste, som. Som, testando. Tá ok? Teste, som. Testando. Testando. Eu acho que você. Eu tô falando baixo. Pra você. Vá lá fora que eu falo normal. É isso. Porque ele
Testando som. Um, dois, testando som. Oi, som, teste, som. Boa tarde. Meu nome é Gabriel. Vou aqui apresentar para vocês meu trabalho sobre sushi e sashimi. Ohayou gozaimasu. Testando som. Oi, som, testando. Ih, é verdade, esquecido. Verdade, tá gravando. Mas depois a gente tira, porque. Testando som. Um, dois, testando. Oi, som, teste. Oi. E aí, beleza, professor? Tudo bem? Testando som. Vê lá com a Lívia se tá funcionando. Quero saber. Testando som. Um, dois, testando. É, E aí, Will? Tá ok? Tá bom?
Testando.
Boa tarde. Vocês me escutam lá no fundo? Todo mundo está escutando? Então, esse encontro acontece aqui graças à colaboração de vários cientistas aí da diretoria, digamos assim, da Federação Internacional de Processamento de Informação. E aí vocês conhecem já a programação, não preciso repetir, mas eu vou chamar o presidente da IFIP agora para fazer a primeira apresentação e agora vai ser em inglês tudo. I'd like to invite Mike Hinchey, that's IFIP president, to give the first presentation. And please welcome him. Thank you very much for having accepted our invitation to give this talk. And we have also, we are transmitting this talk live, so there are connections there as well to different parts of Brazil. Yeah, so thank you very much. So Mike is a well-known professor, and I also distributed all the information about all the speakers. So just passing to him now.
Thank you, and thank you everybody for coming. And on behalf of all of us, thank you for your invitation to join you today. I'm going to give a very short presentation just to let you know who or what IFIP is. Maybe the name is a bit confusing because information processing is what in the 50s and 60s they called what we now call IT or ICT, but we didn't see a point in changing the name. So I'm going to start with a very short video. All the people in the front row are bored. They've seen this like 500 times. Right, Hugo? So I think probably the video explains better than I can, but IFIB was established in 1960 by UNESCO following probably one of the most important computer congresses in the world, which was in 1959. And as I said, back then it was called information processing. We've come a long way since then. So we're a non-governmental, not-for-profit umbrella organization. So we bring together a number of computer societies from around the world. We follow a UN-type model, so we have one member per country, although we've recently changed that. So our goal is to achieve worldwide professional and socially responsible development and application of ICT. So we accomplish this by enhancing international cooperation amongst individuals, national and international organizations in all aspects of research, development, and application of ICT. And we do this by exchanging information, by educating people, by enhancing public understanding and making policy statements, and bringing together professionals in conferences, workshops, in working groups, in technical committees, and in various other ways. So we're unique in our structure that allows us to do this, because what we do is we bring together more than 55 representative organizations. So as I said, typically we have one member per country, and SBC is the member for Brazil, and that's why we're here. Altogether, we have roughly 500,000 individual members, because each of the members of those societies is a member of IFIB. So if you're a member of SBC, you're a member of IFIB, you get discounts at IFIB events, and you're welcome to participate in IFIB working groups and technical committees and so on. So we have about 3,500 people who are actively involved in these working groups and technical committees. They come from industry, they come from academia. We have a young professionals group called Intriate, and that's particularly focused on people under 35 years of age who are either still studying or have recently gone into the job market and are in the early stages of their career. We have a number of very important relationships, particularly with UNESCO, who was our founder. We're looking forward to having our 60th anniversary at UNESCO headquarters in Paris next year. and we work in a number of UNESCO events. In particular, we work with WISIS, which is the World Symposium on Information Systems, and we have 2 events at that, which is actually next month in Geneva. And today we were asked to be part of the opening ceremony and to give a speech at that. So that's something big that we didn't have in the past. We've been working with the UN Commission on Science and Technology for Development, and again we have an event at their meeting in Geneva in June, and I took part in their what they call an intersessional back in January. We work with the ITU, the International Telecommunications Union, of course is also a United Nations body, and we're a member of the International Council for Science. So we have individual members, we have society members, we have volunteers, we have people who do the actual technical work, and of course we have a small staff based in Luxembourg, which is just outside Vienna in Austria. So our membership is we have a country representative member, so each country that is a member of IFIP has 1 member. Typically it's a computer society. There isn't a rule that it has to be, but usually it is, and in the case of Brazil it's SBC. We have some members at large. We have 2 categories of this. We have international members at large. At the moment we have 1, which is the ACM, which many of you will be familiar with. And we have just 1 national member at large. We just introduced this category last year, and the 1 national member at large is IT Ukraine. So Ukraine is actually the first country to have 2 members. We have associate members like VLDB, which many of you may be familiar with. Also CEPIS, which is also an umbrella group, but it is for an umbrella group for members in Europe. So it's all members of the European Union. And we have a number of honorary members. I think at the moment it's 8 honorary members. These are people who have given distinguished service to IFIP over the years, and we recognize that status by giving them membership, and that means they can attend our meetings, our important meetings, our General Assembly, which is typically in September, October, and they have a vote in that. As a substructure, we have a technical assembly, which is composed of 13 technical committees covering all sorts of different areas. These are divided down into working groups, so there's more than 100 working groups who get together and do research, run workshops, run conferences, run events, and some of these work together. And to recognize this, we have a number of domain committees where working groups work together on a topic such as, for example, disaster mitigation. Yuko, see, she's not paying attention. IoT and cloud computing. We have a number of standing committees that address various issues and task forces. We have a members' societies assembly, so the members have a smaller grouping that represents their interests. Intriate, I mentioned already, is our young IT group. And then IP3 is a very important part of IFIP. It's concerned with professional practice. And it is dealing with codes of conduct, codes of practice, and also certification of members as being up to a certain level of competence in doing their jobs. I won't go through the individual technical committees, but they range from foundations of computer science, which is essentially theory, through software, which addresses all sorts of aspects of software and education, all the way down to artificial intelligence, human-computer interaction, and entertainment computing, which is, as you might expect, games, but also things like entertainment systems in cars and so on. So we range quite a whole area. So we have a domain committee on health informatics, on cloud computing, disaster risk reduction, and the Internet of Things. Terrible name, but we're stuck with it. So in the future, we want to expand our membership. We want to focus on producing quality, top-class outputs, which we've been doing for the last 59 years or so, and we want to keep doing that. We have a digital library that we're expanding and enhancing. We're giving inputs to policy-making bodies like UNESCO and the UN. In fact, we've become much more active in that in the last couple of years. And of course, we want to collaborate with various other people in various areas and to address societal needs, specifically the UN Sustainable Development Goals. Okay, thank you very much. That was just a short intro to IFIP.
Have any questions? If not, okay.
It was such a good presentation.
Yes, no. Thank you very much, Mike, for your introduction to IFIP. I'd like to invite then Professor Franz Hamey. Oh, you have a question, okay.
as you were very fast, I didn't process so quickly. No, I have two questions. First, what is the relationship with UN in terms of political decisions? I mean, are you submitted to UN, or what is exactly the IFIP? What it decides something? It's totally autonomous, or there is some dependency? And the second question is about finance. How is it funded?
Well, the first question is fairly simple. We don't have a vote in the UN, but we contribute to UN policy decisions. We can give input to the UN. So we don't actually have a vote or a technical voice in that sense, but we can contribute. We work with a number of various committees and commissions within the UN, and they listen to us, they talk to us, they invite us to come and speak at their events. So our feedback from our members is given to them that way. On financing, each member pays a fee, which is based on the UN scales. So it's related, in theory, to how rich your country is. In reality, it doesn't quite work that way, but it ranges from quite cheap to fairly expensive. But that's one income that we have. The other income is from publications. We get royalties on our books. Kai can tell you exactly how many books we published last year, but it was in the 120 range, something like that. 48? The other ones are the freebie ones, yeah. But so we get royalties on 48. We also have other means of publications. We have a number of workshops and conferences. Some of these, as if you've run a conference or a workshop, you know many of these make losses. Some make a little bit of money, and so that's another form of income. So basically, it's from running events, publications, and the member fees. Don't think I want to answer that question.
Okay, it's actually IFIP is a non-profitable organization, so it has to run just to pay the expenses of operation they have. But I'd like to invite Professor Franz for your presentation, please. Professor Franz from Paderborn University has been here quite a few times actually, and you have seen he's quite active in this collaboration between Brazil and Germany. Also, there is a funding mechanism between Germany and CAPS in Brazil, and he's the guy from Germany who runs this cooperation, and he has worked a lot in his adaptive embedded systems. So we have some students from mechatronics here and also computer science. I think they are quite interested in the things you have to say.
Yeah, thank you very much. So I remember that I've been in this room a couple of years ago when celebrating Professor Macedo's distinctive, the anniversary of his distinctive institute. It was 10th? Or? Oh, okay, the laboratory. Okay. What I would like to speak about today are digital twins and the role in engineering. So just to give an idea what digital twins are good for, it's a slide from the Technical University of Denmark and deals with windmills. So you see the blades are built, and as any kind of engineering means, you produce documents. Of course, a numerical model of the blade is constructed as well, otherwise it would be impossible to make the blade. In reality, in the production process, there will be some defects. That's unavoidable, and now it makes sense to have to model these imperfection in the model as well. And then, when being deployed, some more defects can happen. For example, in Europe, you may have hailstones. I think you don't have them so frequently here, which may cause some damages. And again, you can model these damages as well. You deploy anyhow sensors along the blades, and with the information, and that's important, the exchange of the continuous exchange of information in between the physical reality and the model allows us to have a numerical modeling of the defects, knowing the information from the sensors. We can then experiment with repairs for these defects and play them back to the real blade. And with the sensors, we even get the feedback whether this repair was successful or not. So just to give you an idea what digital twins are good for. And that's the outline I want to speak about. I will try to define what is a digital twin, speak a little bit about the design process and modeling techniques. We want to have executable models, so I have to speak about execution engines, and then some application areas in around cyber-physical systems. So there, as whenever in computer science, when we invite some buzzwords, there are dozens of definitions what we shall understand. So let me try to use a definition by these authors here. They say a digital twin is a dynamic virtual representation of a physical object or system across its lifetime. That's important. So we do not end by engineering. It's across a lifetime. Using real-time data, we are seeing that the sensor information is fed back to enable understanding, learning, and reasoning. And so that's a nice picture by Siemens. You see this digital twin following the physical car. We have this in a couple of engineering disciplines. Interesting enough, the civil engineers now are very active in a field which they call BIM, Building Information Modeling. And again, it includes all aspects of planning, building, financing, maintenance, whatever you imagine is included in this model, and all the parameters and the interrelationships. So that's a way they can more efficiently design and operate complex buildings. This year we celebrate 500th birthday of Leonardo da Vinci, and this brings us back to modeling. So of course, whenever you are doing engineering, what is engineering? And engineering is the process to create documents and to modify them. And so you see here some model, non-electronically readable, of course, but a model of some engineering object. Something is strange here. Let me see why. Ah, okay. So it's the wrong way. It's not my own computer, and therefore the animation works not properly. So I wanted to go from left to right. So just historical points of view. So in the beginning of traditional engineering, engineering documents are not available in digital form. They has to be interpreted manually. And modifications of documents means hard work, as you see here. It becomes better if we are in engineering with digital documents. They cover the entire design phase and could control the manufacturing, and partially are executable. But of course, the remaining life cycle is somehow supported by these digital documents, but not completely. And the consequence, the next step then are these digital twins digital documents for the entire life cycle. So they have to be fully executable with arbitrary precision and has to consider physical real-time data going back from the sensors to the document. And this enables them to support also aspects like safety and security, adaptation, optimization, and supporting the everyday operation of the objects. There are a couple of properties of digital twins. I don't want to read them all. But again, what's essential that they continuously exchange information with the related physical object. Now, let's look at modeling techniques. The main modeling techniques we are using in computer science today are either or both of them object-oriented engineering and aspect-oriented engineering. So in the object-oriented engineering, we partition our problem into different objects which mutually influence each other. We are providing the underlying models at various levels of abstraction. And so we can cover by this the structure of a system based on objects, as well as the behavior based on the behavior of the objects. And what's important, we are making a distinction between object classes and instances called objects. In aspect-oriented engineering, we look mostly what we are interested in. So we decompose a system into various concerns, the aspects. And we try to consider this concern separately. And so in aspect-oriented modeling, we have to identify, specify, and represent all these cross-cutting concerns and their modelization into separate functional units. Of course, what we need is an automatic composition into a working system, especially with the correct weaving of aspects. So these are the basic modeling techniques we are using. Next step is, if we have just a model, we want to bring in life into it. So we have here a model, which is static, and then we have an execution engine, which makes this model an executable one. So for making a model an executable one, we have first of all to classify the information which we find in the model into static data, mostly called parameters. They remain the same over lifetime in the model. And dynamic data, we call the variables, which changes during lifetime more or less frequently. And executing means that we add this execution engine, we bring in a time dimension, and the inputs are external inputs, triggers, and the current value of the dynamic data. And the output is then the next value of the dynamic data and external outputs. So we see it here again, when this digital twin consisting of static data, parameters, dynamic data, the variables, and computation instructions how to handle the dynamic data. And then the execution engine follows these instructions and calculates based on the current value of the variables the next one. So either by differential equations, we are some function of the current value, the derivatives, and the inputs, or here you see the notation which we have in discrete system in finite state machines, where we have the next state of the system calculated from the present state and the input. So that's a very old idea. Goes back to the theory of differential equations, and has been applied in various ways to various areas. We have two classes. We have stabilizing systems which converge towards a stable state, and it can be distorted only by external triggers, or we have inherently unstable systems which can be interpreted as self-triggering systems. just to give an example, gate logic. So this here we have a representation of a function. This Q is always, at any point of time, it is a function of values which we had at the input sometime earlier. And what means sometime earlier is part of the specification of the used gates here. But it's important to mention that this is an equation. This is always a function of the input. Sometimes it is complicated to explain students that the way we are calculating here the equations, the individual equations, is irrelevant. It has, it's not necessary to calculate this first and then this, as the entire, it is a combinatorial circuit, is just a function. It's a function over time. Another decision which we have to do, well, in theory it is possible to have one single universal digital twin. And we can provide a model and the execution engine for each level of abstraction at each aspect. So whatever we are interested in, this all may be a part of this universal model. This would be bloodily inefficient. Therefore, usually one works with families of digital twins where each member is dedicated to a specific level of abstraction and a specific aspect. Then, of course, we can optimize the calculations of problems to be solved. However, there's never free lunch. We have to pay for. The question is to keep the models consistent, and we have to look at these interdependencies of the various aspects. So we pay by management effort for gaining efficiency in execution. Already mentioned feedback, and we find this feedback in very different layers. So the target object in engineering, in most cases, it is a system with closed loop feedback. We have seen the design process itself can be seen as such a feedback loop. And even the development of design processes, next meta layer, can be seen as a feedback loop. So here we see a design, and unfortunately it's not so clear. What you see below is that after having a design process, we rate it, whether it is fulfilling our requirements or not, and if not, then we are even able to repair the design process. This brings us to this example, but let me, I think, I always tend to be late, so I will skip this picture here. It just gives you various levels of for feedback in the design. So, what are digital twins good for? Just to mention 3 application areas. One is safety. They allow us to pre-simulate future states. They allow us for online model checking. I will explain what this means. And we always can compare the model versus reality. In security, they are maybe helpful as well, as we have IoT, Internet of Things. This implies, of course, security risks, as we are connected to an unsafe ecosystem, the internet, and connect very subtle and safety critical objects with them. One way may be to encrypt any problematic data, but that's problematic due to limited computational power of the controllers. There is research going on encrypted controllers, which are doing all the control calculations based on encrypted data. At the moment, this is possible only for very restricted classes of functions. An alternative may be that all external signals are filtered by this digital twin, which runs on anywhere in the cloud on computers with much higher computational power, and it is there decrypted and sent to the real object. But now we have to make the assumption that we have a safe channel between digital twin and physical reality. So whatever you do, it's not so simple. A third application example might be self-adaptive systems. So we are transferring the design process to a certain amount into the operational phase. And if we have real IoTs, then we are forced to do this. The environment will change over the lifetime of a system. I mentioned online model checking. What is the idea? Here we are in the model, an abstract model, and we know there might be a couple of initial states, and then we can execute it in the model for some steps into the future. Now the good news, this is a digital twin, so we know in which state our physical object is. And we can abstract this state into an abstract state one, and now we know what starting state we are starting in the model. This restricts dramatically the search space which we have to cover in our model checking. So these are now the possible states which we may reach after certain steps, and if we have our requirements, say, sketched here by two boundaries, as long as we inside the boundaries we say, well, what's going on here is safe, the system can operate in this way. And then we can continue in this step by step. So we are not proving that our system is correct. We are only checking whether our system, within a short time into the future, will operate in a safe in a safe corridor. I mentioned cyber-physical systems, which means that we are combining two things which are completely independent by tradition: embedded systems, highly dependable, predictable, and on the other hand, the cloud, a chaotic system which can be characterized mostly with probabilistic methods. So we bring this strict world of real-time computing in connection with the cyber phase, which of course causes a lot of problems as we are combining two worlds which in the beginning do not fit, and even the communities doing research do not know each other. And one way how to solve it, that we say, well, we are following this idea of online model checking. We do not require that a system needs to be always correct. It has to make local guesses, and if we at some time we get the global information, we can check whether our local guesses have been correct, and if not, then we correct. as we depend in IoT on channels with non-guaranteed runtime. So we can never guarantee that we have the most recent information about our environment. And so that's the only chance to do, to make guesses and repair if necessary. And the digital twin will help us. Let me skip this. The digital twin can help us, and I will, and I'm coming to the end, shortly explain how another feedback loop, you see I like feedback loops, it goes back to work by Mary Shaw, describing such adaptable systems as in this way as a feedback loop. So first of all, we have to find out whether it is necessary to adapt. And that means we have to check whether our objectives are still met by our embedded system and the operating environment. So we have to model both. And so we have a model of the current and future states, and we have to check whether our objectives are still met by this. And this can be done by model checking. So we have our requirements, what do we want to achieve, our assumptions, which is nothing else than the model of the environment, and from this we should be able to conclude the specification of our system. And if this fails, the only point where we can play with is our specification, the model of the embedded systems, as the environment is given, and let's assume at the moment that our requirements have to be fixed as well. The transformation from the specification to the implementation is assumed here to be to happen automatic. And the way how to make this check is already explained. It is this trick of online model checking. Now let's assume that we did find out we have to do something. So next what we have to do is to plan the adaptation. You may have read this MAPE architecture from IBM describing a very similar loop. I give only some ideas. We assume that we have some ecosystem where in the web we have available components which we can collect automatically to a system to solve our problem. And we have a rather large project running at our university how to do this, how automatically compose from an ecosystem of components the resulting system, and what components to select. Well, we can use the counterexample provided by the model checker to steer this selection process. But now we are confronted with the next problem. We have to effect the adaptation, and we have real-time systems. So we must be sure that what we has as a result of the adaptation is consistent with all the real-time requirements which we have. And even the repair process itself runs under real-time constraints. Again, this works from my point of view only if we restrict ourselves on a fixed ecosystem. And our ecosystem consists of classes of components, and in each class we may have one or more objects for this class. So there may be one or more instances for this class, and they all share the same principal operation, but providing the service with different costs and different precision. And usually the quality of service providing becoming higher means we need more time to calculate this. And this gives us the freedom to find a solution which provides, under the real-time constraints, the best possible quality. And we are working with periodic and aperiodic tasks, assuming that they all are hard real-time and making use of all the entire toolbox of real-time computing to solve this. What we have to solve is a system, a problem like here. We need, for an adaptation, we may have to add an additional component. We need processor bandwidth for this. At the moment, there might be no bandwidth free, but if we replace one component by another one, which is running at lower quality but needing less time, we may gain the bandwidth which we need to include the new component. This is how this situation looks mathematically. People in algorithm immediately see what we have to solve. We have to solve a knapsack problem where the constraints are the real-time constraints, and what we want to achieve is over all the components which we have in the system, the highest overall quality which are within the bounds of our real-time constraints. And therefore, for periodic and aperiodic processes, these requirements look a little bit different, and but I don't want to go through the equation here. Well, now we have our adaptation implemented, but of course in a safety critical system we have to mistrust the result, so we have to check whether the result is correct. And we have, unfortunately, again, some aspects to weave which are not so consistent. So usually if we have anomaly detection, we know what is normal behavior and check whether our system has normal behavior, but we did self-adaptation. So we have autonomous changes. So what we just can say, well, we guess that it is maybe normal, it may be suspicious, or we know that's malicious. And to make it even more complicated, we have real-time systems. So we have very strong restrictions concerning memory usage and runtime. And bringing all this together is what we have to do. In our approach, we abstract it to situations which are really critical, namely the system calls. We can allow our algorithm to do what they want. As long as they are not making a system call, it cannot cause any problems. As whenever it communicates with another process or causes some actuator to do something, we have to make a system call. And therefore, there's a couple of literature saying analyzing a system, the best way of abstraction are sequences of system calls. And but then we have all the necessary parameters and aspects to use artificial immune systems, more precisely danger theory, and map our problem on this field, which is rather well investigated. That's the resulting architecture. I will skip it, and I came to the end. So we have seen that digital twins constitute a natural extension of classical digital design documents. And as they are executable, they span over the entire lifetime of any kind of product, offering any kind of services. So it's a very universal concept. I discussed shortly universal digital twins versus families, and I mentioned 3 possible application areas, and therefore, obrigado pela sua paciência.
just curiosity.
Composition is with real time is really challenging, isn't it? So congratulate for your nice presentation. Makes it really clear the problem. What are the best approaches when you have to search in the solution space, trying to find the optimal composition for a given time? You have a specific techniques applied for real time, or use ordinary optimization techniques?
Yes, we are in the area of configuration systems, which again is a well-studied field. And there are various techniques how to configure automatically systems. It's going back decades, the research in this area. And in more recent times, techniques of machine learning are applied to find similarities, to select quickly what kinds of components may fit to the requirements. So this means reducing the search space. So that's, I think, the direction where people are going at the moment.
Any question more? Thank you very much for the nice talk. So I'd like to invite Professor Gabriela Maran, who is never been to Salvador the first time, but she's been to São Paulo in Rio. And she was the CLAY president for some time. So know Brazil quite well. And she's going to speak in Spanish, so to make a change in the auditorium. She's a professor of computer science in Costa Rica University.
How do you present?
What do you want?
To present it.
It's over there.
Ah, also okay. Okay. Ok, buenas tardes. Voy a hablar despacio porque en español hablo muy rápido. Y mi disculpa por no poder hablar en portugués. En realidad yo soy la directora de un programa de posgrado en Costa Rica, en la Universidad de Costa Rica, y me gusta motivar a los estudiantes para hacer investigación y para hacer investigación que sea útil para nuestra América Latina. Estamos en un contexto donde la investigación en computación va más rápido de lo que nosotros podemos imaginarnos. Pero tenemos que tomar conciencia de que la investigación en la tecnología tiene que tener algún propósito. Y ese propósito tiene que venir para resolver los problemas que a nosotros nos atañen. Por eso es que hoy no voy a hablar de mi investigación, sino los voy a motivar para que hagan investigación en cosas que considero que son muy útiles. Y esos son los objetivos de desarrollo sostenible que las Naciones Unidas nos proponen. Es una forma de ver la investigación con la idea de que no sea un fin en sí misma, sino un medio para lograr una mejor sociedad. Esto de los objetivos de desarrollo sostenible, que ya Mike hizo referencia, en realidad yo no sé cuántos de ustedes han visto esos objetivos. No son tan poquitos. Es como 3 o 4. En realidad yo tampoco los había leído nunca, son 17, son un montón. Pero son simplemente una forma de organizar la problemática que enfrenta el mundo para dar mayor calidad de vida a las personas y para hacer que sea sostenible en el tiempo. Y entonces es una forma de decir, hay una serie de retos que son importantes de ser analizados desde todas las perspectivas. Y bueno, las Naciones Unidas, que siempre es muy idealista, se pone unas metas y dice para el 2030 vamos a lograr obtener todo esto. Y créanme que para 2030 parece para ustedes que está muy lejos, pero para nosotros que somos más viejos sabemos que eso está a la vuelta de la esquina. Y entonces va a ser bien difícil alcanzar las metas del 2030 si no todos trabajamos para tratar de acercarnos. Vean, esta es la lista, tiene bonitos colores. Parece como construido en Salvador de Bahía, es más, parece la fotografía del centro histórico, pero si los vemos en análisis, en realidad son bien interesantes. Vean que estos objetivos son en realidad responsabilidad de los gobiernos, de cada país, y además el gobierno no puede hacer mucho sin que la sociedad civil realmente participe en ayudar a obtener las metas que nos hemos planteado. Estos objetivos son continuamente medidos y de los 17 han hecho un scoreboard que es simplemente una forma de medir cuán lejos o cerca está cada país de alcanzar estos objetivos. Y se tienen 240 indicadores. ¿Quién mide eso? Eso lo mide cada país y lo autorreporta. Eso quiere decir que si el gobierno es honesto, reporta correcto, y si no es tan honesto, reporta no tan correcto, pero en realidad podemos engañar al mundo, pero no nos podemos engañar a nosotros mismos. Cada país sabe si tiene problemas sociales, si tiene problemas económicos, si tiene problemas de medio ambiente, y tiene la responsabilidad de velar por su propio bienestar. En particular, en Brasil, la institución encargada de estar monitoreando el avance es el Instituto Brasileño de Geografía y Estadística, que ustedes lo conocen mejor que yo. De hecho, es interesante, gracias a Internet uno se entera de lo que pasa en otros países, y entonces aquí ustedes están bastante bien organizados. Tienen la sociedad civil trabajando por los objetivos de desarrollo sostenible, tiene al gobierno y tiene un montón de iniciativas que poco a poco contribuyen. Ahora, ¿qué tiene que ver esto con todos nosotros? ¿Alguna vez se han puesto a pensar cuál es nuestra responsabilidad como profesionales en tecnologías de información y comunicación? ¿Qué es lo que tenemos que hacer? Y aquí es donde vengo a enamorarlos de que algún día sean investigadores. Algunos de ustedes están en pregrado, otros tal vez están en posgrado, pero en realidad uno tiene que soñar porque algún día no sea solo consumidor de conocimiento, sino de alguna forma llegar a ser productor de conocimiento. Y productor de conocimiento que sea útil para todos nosotros. Y ahí es donde comenzamos a ver cada uno, y voy a ir rápido porque son 17, pero en realidad vean que los objetivos suenan muy bien. El primero es, eliminemos la pobreza. Obviamente, eliminar la pobreza no es fácil. Entonces, ¿qué podemos hacer nosotros como personas que trabajamos en computación? Y ahí es donde, de alguna forma, tenemos que tomar conciencia que una cosa es la investigación y las tecnologías que existen y el potencial que tienen las máquinas para hacer cosas, y otra es la realidad de dónde usamos la tecnología y cómo la usamos. En este caso, vean que yo no sé cómo será en Brasil, pero en mi país y en muchos de los países latinoamericanos, cada instancia gubernamental maneja sus bases de datos, y si usted trata de determinar dónde están los pobres de un país, un ministerio va a decir, esto es el grupo de pobres, otro ministerio va a decir, este otro es el grupo de pobres, nadie se pone de acuerdo dónde están los pobres y a quiénes tienen que ayudar. Entonces comenzamos a tener que ofrecer la integración de bases de datos heterogéneas, a ofrecer algoritmos para hacer minería de datos especializado y bien inteligente, bien eficiente, de tal forma que pueda trabajar sobre bases de datos que están distribuidas remotamente. Y no solo basta con detectar dónde están los pobres, hay que detectar dónde están los recursos para ayudarle a esos pobres. Y entonces, de alguna forma, hay que hacer minería de recursos para ver cómo puedo hacer un match entre esta persona con necesidad y estos recursos que se le pueden ofrecer a estas personas. Vean que, de alguna forma, tenemos que ayudar a que haya un linkage y la economía funcione más eficientemente. El segundo, vean que eso suena casi irreal. ¿Cómo nos vamos a morir de hambre? Pero en el fondo tenemos que garantizar que el mundo produzca suficiente comida para todos. Y eso es una responsabilidad no solo en los países desarrollados, sino en nuestros países también. Y entonces tenemos que ofrecer ayuda técnica a los agricultores. La agricultura tiene que ser más eficiente en cualquier parte del mundo, y eso pasa por diferencias en las condiciones climáticas y en las condiciones de uso tecnológico. En Costa Rica ahora estamos haciendo una pequeña investigación donde tratamos de hacer agricultura inteligente al menor costo posible, porque las compañías que ofrecen agricultura inteligente ofrecen un montón de Internet de las cosas bien sofisticado, pero es sumamente oneroso y eso no puede llegar al pequeño agricultor. Entonces vean que de alguna forma tenemos que hacer agricultura de precisión y nosotros podemos todos ayudar porque nuestras condiciones son muy diferentes a las condiciones donde se hace la investigación para esto. Y finalmente, cuando el agricultor produce, tiene que distribuir sus productos. ¿Cómo hacer que ese agricultor pueda llegar a los mercados más eficientemente? La tercera tiene que ver con salud. Todos estamos interesados en llegar a muy viejos y estar muy saludables. Así que vean que las tecnologías también tienen la posibilidad de ayudar a monitorear el estado de salud del individuo. A mí me interesa que de alguna forma me monitoreen para que puedan determinar si soy saludable y lo hagan costo eficiente. Pero de alguna forma también tengo que llegar a los servicios de salud. Y en países tan grandes como Brasil, me imagino que la medicina debe ser de mayor calidad en los centros urbanos que en las zonas rurales. Y por lo tanto, nosotros podríamos ayudar a que gente que está en forma remota tenga acceso a los servicios de salud de calidad que podría tener alguien en una ciudad. La última es la más interesante. ¿Cómo se transmiten las epidemias? No solo hay que monitorear al individuo, es nuestra responsabilidad generar tecnología para monitorear al colectivo, de tal forma que podamos prevenir la diseminación de las enfermedades. Entonces vean que podemos hacer cosas bien interesantes. El computador tiene tanta capacidad que podríamos ayudar a garantizar no solo la salud del individuo, sino del colectivo. Bueno, todos ustedes tienen acceso a educación de calidad, pero no todos en el planeta tienen acceso a educación de calidad. ¿Por qué? Porque quedan muy lejos los centros de educación o porque hay pocos recursos. Y entonces la tecnología puede ayudar a llevar la educación hacia zonas remotas. Y entonces tenemos todo lo que es e-learning, pero también podemos llevar educación a poblaciones desprivilegiadas. Y por ejemplo, apoyar a muchas mujeres para que estudien computación, qué cosa más terrible. Aquí veo muy pocas. Entonces, ¿y por qué es eso? Porque desde niñas tenemos poca posibilidad, en muchos casos, de usar tecnología desde pequeños. La tecnología se reserva para los hombres o para el grupo dominante en cualquier sociedad. Entonces, vean que de alguna forma tenemos que desarrollar mecanismos de enseñanza personalizados, porque yo aprendo diferente a como aprende él o aprendes vos, y a través de la tecnología podemos hacer mecanismos de enseñanza que se adapten a la velocidad o a la forma en que las personas quieren aprender. Crear interfaces inclusivas, por ejemplo, no es lo mismo, y créame que no es lo mismo, enseñarle a una persona que tiene la capacidad de vista a tener en la clase a alguien que no puede ver. Y me ha tocado ser profesora de alguien que no puede ver y enseñarle tecnología a esa persona. Y créanme que la que más aprendió fui yo, porque es bien difícil enseñar a personas que tienen condiciones diferentes. La educación es la forma de ascenso social. Así que para nosotros es una responsabilidad hacer llegar mecanismos de educación a todos los sectores de la población. Este es el que más me gusta, es en el que me siento una minoría. Y créanme que para los que nunca se han sentido una minoría, sentirse minoría hace, o por lo menos ya con mi edad, hace que uno diga, hay que hacer algo para evitar esas minorías. Y entonces vean que a través de la tecnología podemos empoderar mujeres. Si las mujeres no se les permite salir de sus casas, podemos llegar a esas casas. Si a las mujeres no se les da acceso a tener mucho tiempo para dedicarle a aprender, tenemos que facilitarle el proceso de aprendizaje. Tenemos que llegar a esas mujeres en términos no solo de que aprendan a usar la tecnología, porque la tecnología no es un fin en sí misma. Hay que empoderarlas para que usando la tecnología mejoren la calidad de vida. Y entonces la forma de llegar a ellas es bastante diferente. Los cursos típicamente son, vamos a enseñarle a las mujeres a usar la computadora y le damos Word y acceso a Internet. Eso no es suficiente. Tenemos que generar la posibilidad de que ellas tengan acceso a ganarse la vida, a unirse para luchar por sus derechos. Y entonces vean que a través de la tecnología podemos llegar a ellas. Pero el más radical de todas mis investigaciones tiene que ver con esto. ¿Cómo hacer que la tecnología sea sensitiva a las diferencias entre hombres y mujeres? Y crear interfaces que me sean fáciles de manejar a mí, así como algunas interfaces son fáciles de manejar a los hombres. Y vieran que es bien interesante darse cuenta cómo cosas que para los hombres es bien sencillo, para las mujeres no lo es tanto, y se los voy a decir. Cuando vinieron las tabletas, los primeros tablets, cut and paste, era una cosa que los hombres podían hacer súper fácil e intuitiva, y porque yo no podía, a mí no se me ocurría cómo hacer cut and paste, y yo llevaba años de estar trabajando en computación. Yo decía, esto no puede ser, ¿cómo no puedo hacer cut and paste en esta tablet? Y entonces comencé a preguntar a ver si yo era la inútil o la vieja, la obsoleta, y un montón de mis compañeras, mujeres y de las estudiantes, no les era nada intuitivo hacer cut and paste. Vean que entonces tiene que ver con que los que diseñan la tecnología lo hacen fácil o user friendly para sus propias realidades. Y como la mayoría de los diseñadores de tecnología son hombres, pocas mujeres tenemos acceso a incidir en cómo se diseña esa tecnología. Esto tiene que ver con la naturaleza y tenemos una responsabilidad real. Tenemos que ayudar a través de la tecnología a mejorar aquellas cosas que tienen que ver con el agua limpia, el agua sucia, cómo hacer para monitorear las disponibilidades de agua o cómo hacer para llegar y medir en forma equitativa el acceso al agua. Y finalmente, bueno, dentro de esta línea, cómo generar energías limpias. Y vean que a través de la computación podemos monitorear el uso de la tecnología, de las diferentes formas de producción de la energía, pero además podemos tener lo que se llama una batería inteligente de fuentes de energía. Y entonces cuando hay lluvias, usar energía producida por el agua. Cuando no hay lluvias, entonces cambiar automáticamente a otras fuentes de energía. Y eso todo lo podemos ayudar a través del computador. Vean que esto es interesante. Tenemos que generar empleo. Es una responsabilidad, o generar fuentes de riqueza, como lo quieran ver. Todos mis compañeros aquí de la primera fila, que casi todos vienen de Europa, están conscientes de que la tecnología está transformando la forma de emplear o no emplear a la gente, y en muchos casos está generando desempleos estructurales. Los empleos están cambiando, pero tenemos una responsabilidad para con todos nosotros. En América Latina esa preocupación no se oye en ninguna conferencia. Es dificilísimo ver a alguien que diga, tenemos una responsabilidad porque estamos automatizando procesos y estamos sustituyendo mano de obra por capital. Acuérdense de Marx, en algún momento habló de eso, la sustitución de mano de obra por capital. Y lo hizo en un momento donde realmente la sustitución no era tan radical. En este momento, muchos países dependen de los call centers, incluyendo Costa Rica. Ha apostado a call centers. Son los centros de respuesta telefónica a las grandes corporaciones. ¿Qué tarea puede ser más fácilmente sustituida por un computador con un mínimo nivel de inteligencia que un call center? La inteligencia artificial va a sustituir, va a desaparecer muchísimas profesiones. Es más, se habla que los médicos van a estar masivamente desempleados. ¿Por qué? Porque simplemente un sistema experto puede hacer un mejor diagnóstico que un médico normal. Un sistema experto bien programado tiene acceso a muchos más casos que la experiencia de vida de un médico. Entonces vean que tenemos muchísimas cosas que pensar en términos de cómo generar empleo, pero además cómo ayudar a reciclar gente para que pueda insertarse en nuevos mercados laborales. Aquí tiene que ver con los que les gusta la tecnología, las telecomunicaciones, el hardware, cómo producir infraestructura que sea realmente resiliente, que esté disponible. El ejemplo de RAM, de France, tiene que ver con algo que tiene que ver con una tecnología, una infraestructura que sea resiliente. Sin embargo, en nuestros países hay muchísimas oportunidades de mejora para realmente crear una economía que permita compartir recursos. Hay países en América Latina que se quedan días de días sin electricidad, y si no, que le digan a Venezuela qué es lo que le está pasando. En otros países como nosotros, gracias a Dios, no tenemos problemas de disponibilidad de recursos públicos tan seriamente, pero tenemos que contribuir de tal forma de que esa infraestructura no solo nos llegue a nosotros, sino que le llegue hasta la persona que está más remota en el país. Y cómo cómo dar disponibilidad de internet en lugares donde no ha llegado siquiera la electricidad. En nuestros países existen muchos lugares donde no ha llegado la electricidad. Entonces, ¿cómo hacer para hacer eso? Vean que es una fuente de investigación bien interesante. Las tecnologías, vean que nos proponen que tenemos que reducir la inequidad o la inigualdad entre un país y entre los países. Esa es una tarea horriblemente difícil. Es decir, si ya bien es cierto, el desarrollo tecnológico per se genera una brecha cada vez mayor, vean que cómo hacer para que la tecnología en sí se revierta esa tendencia y de alguna forma ayude a aquellas personas con más desventaja a poder acceder a la tecnología. Nos estamos quedando atrás. Brasil es punta en América Latina y créanme, los felicito. Han invertido en investigación muchísimo y por lo tanto tienen la capacidad de, en algunos momento sentarse en igualdad de condiciones con los investigadores de otras partes del mundo. Pero eso no es común en todos los países. Tenemos que aliarnos para crear lo que se llama investigación y cooperación sur-sur, en el sentido de que unámonos como comunidad para poder crear masa crítica y poder hacer investigación. Ciudades inteligentes. La penúltima investigación que hice fue un diagnóstico de la situación de las ciudades inteligentes en América Latina. Y vean que en realidad es interesante porque la tecnología existe en otras partes del mundo, pero en nuestros países esa tecnología no es tan asequible y no es porque sea muy difícil de usar. Los problemas no son técnicos, los problemas son políticos, de asignación de recursos, de disponibilidad, pero también de crear en un país la sensación de que las cosas pueden cambiar y que los gobiernos pueden ser actores importantes en los procesos de cambio. Pensar a largo plazo y no tanto a corto plazo. Y vean que esto no tiene nada que ver con tecnología, pero es una cuestión de que si todos cambiamos la visión de que pensemos a largo plazo y no a corto plazo, tal vez podamos ayudar un poco a que nuestras realidades cambien. Vean que los patrones de consumo y de producción, todos tenemos una responsabilidad para con el medio ambiente. ¿Cuántos de ustedes reciclan? Vean que son pocos. Todos podríamos reciclar. Y reciclar cosas como nuestros celulares o nuestras computadoras o muchas otras cosas que consumimos. Pero además tenemos que pensar en mecanismos más eficientes de ofrecer la computación. Cosas como cloud computing, smart grids, smart metering, reduce energy consumption. Esos términos no son nuestra realidad típicamente. ¿Alguna vez se han puesto a pensar cuánta energía y cuántos desechos producimos nosotros a través del uso de las computadoras? Entonces tenemos que estar un poco más conscientes de que si bien es cierto eso es bueno, también genera algunos problemas para con el planeta. Y tratar de reducir lo que se llama e-waste, que es toda aquella basura que generamos los tecnócratas. Cambio climático, todos sabemos que es cambio climático. A veces llueve cuando no tiene que llover, hace un calor terrible cuando tiene que ser frío. En mi país cuando llueve se inunda todo porque llueve tan rápido que no da tiempo que el suelo acoja la lluvia, simplemente porque hay demasiada superficie con concreto o por algunas razones estamos siendo asediados por el planeta. Las computadoras podemos utilizarlas como mecanismos de monitoreo de cambios. Todo esto de Internet de las cosas nos puede servir para censar cosas que antes no podíamos censar. Por ejemplo, censar cambios en los parques nacionales. En mi país estamos orgullosos de tener muchísimos parques nacionales. Y entonces tenemos una responsabilidad para con el planeta de usar la tecnología para monitorear los cambios, pero también para alertar a las personas sobre posibles desastres naturales. Y no solo alertarlos, sino cuando un desastre natural ocurra, y ojalá que no nos pase, cuando haya un terremoto o un tornado o una inundación, llamamos a Yuko, que es experta en desastres naturales, y ella nos ayuda a usar la tecnología para tratar de prevenir los desastres, pero también para poder responder en formas más eficientes ante situaciones de desastre. Nos faltan un montón. Vean que ahora tenemos que monitorear el mar. El mar es nuestra fuente de riqueza y por lo tanto podemos utilizar sensores o mecanismos de control que nos ayuden a saber cómo está la vida marina y nos ayuden a extraer riqueza o alimentación de la vida marina en forma responsable. Y además, vean que tenemos una responsabilidad con nuestros bosques. Si los bosques se extinguen, nos extinguimos nosotros. Tenemos que parar esto de la tala de árboles masiva para producir fuentes temporales de riqueza, por ejemplo, la ganadería. La ganadería es una cosa que en nuestros países se da muchísimo, la carne es deliciosa y a mí me encanta, pero vean que tenemos que hacerlo de forma responsable. Y las computadoras sirven no solo para monitorear las situaciones, sino para generar formas de producción mucho más eficientes. Ay, como si no tuviéramos responsabilidades, ahora tenemos que velar por la paz, además. Vean que, y además que tengamos una sociedad inclusiva, y eso es bien interesante. Nosotros, los tecnócratas, difícilmente hablamos de eso. ¿Por qué? Porque estamos preocupados por generar computadoras, pero necesitamos que esas computadoras de alguna forma sirvan para administrar las crisis, para de alguna forma distribuir la ayuda humanitaria, para generar mecanismos de apaciguar la violencia de las sociedades, para ayudar a los procesos electorales. Vean que las computadoras pueden ser utilizadas en muchísimas cosas y nosotros podemos ayudar a que eso sea una realidad. En algunos casos se habla de Open Government, que es una forma de que los gobiernos tengan que rendir cuentas ante la sociedad y así tal vez podamos tener mejores gobernantes. Obviamente esto no es una solución a través de la tecnología, simplemente podemos ser facilitadores en el proceso. Y entonces vean que el último es de alguna forma crear alianzas, alianzas que nos permitan tres cosas: crecimiento económico, inclusión social y desarrollo sostenible. Son tres objetivos mayoritarios y usar la tecnología para eso a mí me apasiona. Yo no sé si a ustedes les apasiona. Yo prefiero decir que estoy estudiando computación para transformar el mundo que decir que estoy estudiando computación para programar una máquina. Y créanme que con esa visión, yo creo que traeremos más mujeres a estudiar computación. El problema es que nos han vendido la idea que nuestra carrera es solo estudiar para cambiar, para transformar estas máquinas. Nosotros estudiamos computación para transformar el mundo. Acuérdense de eso, porque eso es una guía mucho más poderosa que cualquiera que nos hayan dado. Vamos a estudiar computación para transformar el mundo. Y con eso me despido.
Perguntas? Não?
Eu tenho a ordem das prioridades, assim, das linhas, dos objetivos. Tem alguma a ver com a prioridade desses objetivos? Porque se for o caso, o primeiro, o segundo, o terceiro, eu acho que eu revisaria todinha a ordem. Porque eu quero dizer alguma coisa. É muito sintomática que a gente começa com a luta contra a miséria, para a saúde e para... os três são miséria, saúde e os três primeiros. Pobreza, fome, saúde. Os três, se a gente observa, são três lutas que levam ao consumo, de uma forma ou de uma outra. E a educação, que é o quarto, ele leva a uma cidade de cidadãos politicamente esclarecidos. E não é o primeiro ponto, mas para mim Os outros dependem da construção de uma democracia viva. E no Brasil, hoje, a gente vê isso de forma extraordinariamente forte. Lutar para que as pessoas tenham acesso a um sistema de saúde sem educação é um problema muito grande, porque como que a gente consegue se curar sem ter um senso crítico do que os médicos falam para a gente? É impossível. A gente construir recursos para lutar contra a miséria sem ter educação é impossível. Conseguir se sustentar é muito bonito aprender a ter peixe no prato. Isso se chama Bolsa Família. Mas é muito melhor aprender a pescar. Não foi eu que inventei isso. Né? Então, eu prefiro ensinar a pescar do que dar peixe. Então, esses 3 temas fundamentais, eles levam ao consumo, que é um grande objetivo da sociedade internacional, do mercado internacional, é levar as pessoas a consumir cada vez mais. Saúde, remédios. O consumo de remédio em 10 anos nos Estados Unidos multiplicou por mais de 10. Ou seja, tem interesses políticos nessas prioridades.
Então, passar para a Gabriela comentar.
En realidad vean que las decisiones son todas políticas y cómo se distribuyen los recursos en una sociedad. Y es bien interesante ver cómo algunos países están más conscientes de que la población está envejeciendo que en otros. Gracias a Dios, aquí en Brasil todavía nos reproducimos mucho, igual que en mi país, aunque no tengo nietos, eso es terrible, pero vean que los problemas de salud se acrecientan a medida que la población se envejece. Y entonces, ¿quién va a tener acceso a la salud? ¿Serán los viejos que tienen mucho dinero? ¿O muchos jóvenes que tienen futuro? Curar a un hombre viejo cuesta exactamente lo mismo que darle salud a muchos niños. ¿Quién toma esa decisión? La decisión la toman los gobiernos, pero también tenemos la responsabilidad nosotros de velar por el tipo de sociedad que queremos. Y entonces los llamo a ustedes a pensar y a meditar. ¿A quién vamos a apoyar tecnológicamente cuando hagamos investigación? Yo espero que todos ustedes se queden en Brasil haciendo su doctorado. Y vean que tengo aquí a la barra grande de las mejores universidades. Yo fundé el doctorado en computación en Costa Rica. ¿Y por qué lo fundé? Porque yo fui a hacer investigación para Estados Unidos. Yo quiero que los costarricenses hagan investigación para Costa Rica. Claro, hacemos alianzas con las demás universidades, pero ¿qué tipo de problemas quieren ustedes enfrentar cuando hagan investigación? ¿Los problemas de los países desarrollados o los problemas nacionales? Ustedes tienen una responsabilidad para generar una mejor calidad de vida. Sí, para el mundo, pero también para ustedes.
Excelente a resposta. Eu concordo plenamente eu concordo com a tua visão, né? É isso. Muito obrigado. Graças. Agora a gente tem um intervalo de 20 minutos para o pessoal tomar uma água, um café, e a gente volta com as 3 outras palestras, tá bom? 20 minutes for a short break. Pessoal, vamos dar continuidade às apresentações. Falo para o pessoal que está remoto também, os presenciais. I'd like to invite Professor Kai Honenberg, the Goethe University in Germany. Thank you very much.
Obrigado. Muy obrigado por la invitación a grabar. And that's about everything and very little Portuguese that I can do. So, and es no mejor en la español, perdona. So this is going to happen in English. However, it's a relatively political talk, because meanwhile cybersecurity is becoming a very political topic. And I don't know whether some of you remember Roger Needham. That was the inventor of one of the famous crypto protocols for security, the Needham-Schroeder protocol. He, about 20 years ago, he said security is becoming a people problem. And he was already right 20 years ago. And meanwhile, politicians have kind of understood it. And that is why this project actually is existing. Let me ask you, who of you has been exposed to cybersecurity in some way? Who of you has made some experiences with cybersecurity or with the lack of cybersecurity? Quite a few of you. Who of you is sure that you never had an issue of lack of cybersecurity? Okay, so from that point of view, I hope that may be of interest for you. You may wonder, why am I talking about something that is about Europe? And I'm going to explain that in a minute, but also the other point is, if you like to ask a question during the talk, you're welcome, and also Raimundo has kindly offered to translate Portuguese questions into English, if that helps the dialogue. Because after all, I can tell you, cybersecurity is very much about a dialogue, and from that point of view, the more we have a dialogue, actually, the better. So why am I talking about this project here? There's two reasons. The one reason is actually the European Union, who is sponsoring these kind of things, is interested in Brazilian cooperation, because Brazil is considered a strategic partner. And the other reason is Europe is a federation of several countries, obviously, and states. And part of the problems are because the federation of countries needs to be dealt with properly. Brazil, as you know, is a federation in itself. And at the same time, it is organized within the federation in Latin America, and maybe even Latin America, basically. And again, there's a federation situation, and one needs exchange about these kind of federation situations. So from that point of view, and again, maybe we can have some kind of a dialogue about these kind of things. So the reason why CyberSec for Europe exists is a call that you see here. The European Union has said we need to have all of the cybersecurity research and innovation all over Europe better aligned, better synchronized. They want to set up a new specific body for that. Some of you may have heard about ENISA, the European Network and Information Security Agency that already exists. But this is not enough from the position of the European Union. They want to build something new and bigger. Later we come back to the question why ENISA is not the solution of the problem from the point of view of the European Union. But for the moment, yes, something new should be there. And then the idea was to say, while this is being set up, there should be 4 pilot projects that are trying out what this new European body institution should actually do. And CyberSec for Europe is one of the 4 pilot projects. Some people say we're dealing with the most sexy projects, but that is something that only Mike can explain you why we're doing that. So, and the point is to synchronize research and to drive it forward and to solve the problems that is considered to have Europe happening. So, one thing that you may see here is actually, and that's one of the other reasons, you see CEPIS. Mike mentioned CEPIS. CEPIS is one of the European CyPIS IFIP associate members. And CEPIS is, and we're quite proud that CEPIS got a handle into this now in terms of trying to help things going forward. And apart from that, you see this project is actually having quite a few partners. Almost all European Union countries are involved, 43 partners, so big, big figures. There was a guy who was asking about money. So this is 16 million euro for 3.5 years. So it is not very much money when you talk about 40 partners, but it is some money to try to get something and to try to get something done. And CPIS has a bit of hands in it, and that is good. So, and what does it mean with regard to Brazil or with regard to partners? This is a long list of partners. Goethe University is the coordinator. That is the other reason why I'm talking about it. But some of the partners actually have some relations to Brazil already, and I'm going to come back to them and over the time of this talk. Actually, let me start with University of Luxembourg. Some of you probably know Paulo Verissimo, who used to be in Portugal. He works very closely with Raimundo at least, and probably other people. He's also working in this project. So this is one way, let's say one path, one anchor into this project already with Brazil and with UBFA. Another one is Afonso Ferreira, and he's actually now at University Paul Sabatier in Toulouse. He was at the European Commission before. You so notice from his name already is at least 50% Brazilian. And actually recently, 2 days ago, he was talking in Sao Paulo about CyberSec for Europe in the Forum Brasileiro de IoT. So if you may have seen something in the area of IoT and dealing with it, that is actually another link. But before we go further into this and talk about other further corporations, and let's talk about what actually is this kind of CyberSec for Europe project actually. And I thought the best is probably to give you an overview of the work packages. This is probably difficult to see. Hopefully not to be a problem, I hope this is easier to see, because you see 4 areas of work in which these projects are trying to advance Europe in the field of cybersecurity. It is one, to make sure that actually the research that is happening in cybersecurity in Europe, which is actually not so bad, is arriving more in innovation and in industry. Because the classic problem in Europe is actually you have good researchers, good people, good ideas, good projects, but when they become economically relevant, very often they're basically bought by some startups, very often in the US or in other countries which have a lot of money. And in the long run, this is not a good idea for Europe. So the idea to strengthen the relation between research and innovation and industry is one of the topical areas. And we're going to come back to this red area and describe a bit more on what actually the aim is to overcome this issue. Then one other area is education, training, and standardization. Not enough people know about cybersecurity in Europe. I think that is globally like that. And the lack of people, the lack of skills, is keeping the industry, hindering the industry from being successful in what it needs to do. So some aims are going to deal with that an issue. Then there is something you see, governance, design, and pilot. And that is actually about the European politics situation. And it's now under this new buzzword of governance. We later come back to it. And that is where we will see very closely that cybersecurity is extremely political. And then there is a community building area. Again, it's basically something that I'm trying to do also now to explain what we're doing and trying to get more involvement. So let's start with these work packages 3 to 5. What are they doing? Basically, the idea is, and we're going to see that in a bit more detail here, we're going to try to apply cybersecurity research results to real application areas where really people are not cybersecurity experts, but they have problems. That was actually one of the requests in the call. And here you see some of the so-called industry verticals, application areas where something needs to be done. And let's first look at the areas, and then we later see how the cybersecurity research results are supposed to come in and what they are supposed to do out of it. So there's an area of finance. Finance is always, money is always sexy, so from that point of view that fits. And we have 2 areas basically. The one is incident reporting about what went wrong. That is in general a difficult topic because people do not like to report when something went wrong is critical. They try to hide it for themselves. In the long run, we need these kind of reports because if you don't know what happened, what went wrong, you cannot improve. And so it's about developing a culture of reporting without getting blamed and without embarrassing yourself. And in this area, we do that in the banking area for some banking systems. The other, one of the reasons for that is, again, money is sexy, and the other reason is there were partners who were willing to work with us. One of the challenges in building this project was to find people from the application side who said, yes, we are willing to work with you. It was easy to find researchers in the security side, but it was a challenge to find partners in the application side and say, we have a cybersecurity problem, or we were willing to work with you on overcoming that. And that was the fact that we got this in some areas was probably one of the reasons why this project actually got funded. It was in competition with other projects. So, incident reporting and finance, and another thing, and PSD2 versus GDPR. Anybody of you having an idea what is PSD2? Again, it's relatively political actually, like GDPR. Anybody have an idea what a GDPR is? That has come over probably now. That is one of the European export goods, General Data Protection Regulation. Europe is claiming to be ahead of it, of the rest of the world with this, and certainly it is stricter. And indeed, very innovative ideas are in there to protect the European citizen, even on a global basis. And we can say that even in countries which tend to ignore Europe, like on the other side of the Atlantic or north from here, people are now paying attention because it's about real money. And so it's something the European Union tried to put up good civilizatory values and citizen values forward. So PSD2 is something similar, not so popular yet. PSD2 is a Payment Service Directive. Number 2, there was one before, obviously. And that is about actually making it easier for the citizen or for the consumer to change banks and to not be in a lock-in with one financial institution because you gave all of your data to them, you have your account with them. It's really difficult to move from one bank to another. I don't know how many of you have tried to move from one bank to another. In Europe, it can be quite a bit of a bureaucratic hassle because obviously banks don't want to give away customers, so they make it really difficult for you to go to another one. PSD2 is one of the European regulations, so trying to make that easier, especially also in internet banking, automated banking, to make it easier for new players in the field to get onto the market and offer better service to customers. And one point is transfer data from the old bank to the new bank in a relatively easy fashion. However, how do you make sure that only those data are being transferred from those customers who really want that, especially in a large-scale automated system? And that is a not trivial task. And of course, GDPR is telling you, hey, yes, if you mess up with this, you have a major problem. We had privacy problems already with the digital twin of the car, where we don't know where the data go. So trying to balance these two issues and combining them is a challenge and needs thinking of researchers. And it's a real practical challenge because both of these regulations exist now in Europe, and one needs to make the best out of the combination of both of them. So that's why we came up with that issue. Next one is maybe easier to explain. Health, medical data exchange. Many people want to exchange medical data on platforms so that maybe information from hospitals can go to the doctors who deal with the patient afterwards, or maybe to any kind of people that help people who came out of the hospital. Obviously, these data are very sensitive, so you need to do it in a proper fashion. Smart cities, and we have even cities participating in CyberSec for Europe, like, for example, the city of Genova, directly. And lots of cybersecurity issues are happening now in smart cities. On the one side, all of the critical infrastructures. Think about Salvador not having electricity because the computers would break down. Would not happen here because people in Salvador know what they're doing. But in principle, for a small city, losing electricity or losing traffic lights because the computers are hacked is a major problem. Also, cities are the source of democracy, basically. The root of democracy, if citizen participation is not working because it's manipulated in discussions of social networks or in votings or whatever, and all of these, of course, get more and more computerized, there is a challenge. So from that point of view, these kind of citizen participation and e-government issues are to be considered. At the moment, the smart cities or the city people are discussing which cases they want to look most at. And then, of course, education. At least in many parts of Europe, education is actually done by the municipality. The idea of a federal university like here is not happening in so many European scenarios. And then transport. It happened to be that some partners are good in maritime transport, port infrastructures, securing how to get in out of a port. And last but not least, supply chain assurance. And that is actually not only transport in itself, but it's also transport of software. It is about the whole story of Industry 4.0, smart manufacturing, getting software into any kind of industrial good, like a digital twin or so, and making that secure. So these are the areas which somehow will be dealt with by CyberSec for Europe on the application side. And the methodology that is going to be used is say, hey, we have these issues. The people are coming up with their requirements. And the researchers who have actually sitting in work package 3 and coming up with most recent solutions are trying to attack these problems and see whether they can come up with proper solutions. And the outcome can be twice, of course. The outcome can be, yes, we find actually we have solutions out of the research that we have. And that's good because then we have done an innovation and hopefully it can go to the market and drive Europe forward. But even if it fails, the idea of the project is to say, hey, we need further research roadmaps. We need to do strategic planning for the future research. And we need to make sure that it's not only done by the people who always did the research and want to do the next thing that they always liked to do. There should be a relation to what the real problems of this area are. So when something cannot be solved, the idea is to say, we put that on a research roadmap. If you look again back to this, you see a work package 3 with all of the research, a work package 5 with all of these applications, and a work package 4 which is generating this kind of research roadmap over the time. By the way, if you wonder what kind of new research approaches are considered to be new and to be dealt with, you find a number of them here: software development, lifecycle oriented stuff, security intelligence, adaptive, usable, all of the nice buzzwords, some of you you probably have heard about, but also continuous scouting, trying to take a look and make sure that some things that are not on the list yet are going to be covered. So and that explains maybe this orange cycle in trying to be innovative. Let's go. And one example for that one we can bring in here as an example where there is a Brazilian relation, because one of the partners, which is actually, or two of the Norwegian partners actually, NTNU and Sintef, is partnering up in resilience and safety management for any kind of these critical infrastructure things with a project called Sterna with Brazil. And you see it's about all kinds of areas that Norway and Brazil actually are sharing. And it's going to continue: oil, gas, aviation, construction. So you see some relation, and has some exchanges happening. UFBA is also involved. And I was about to say this is an announcement that is coming now. Per Håkon Meland from Norway is actually going to come. So if you want to learn more about that area, put 10th of May into your calendar, because then the guy is going to be here. And if that is an area, you can talk to another CyberSec for Europe person and deal with them and work with them. And even drones are happening somewhere there. So much for that bit. And again, the outreach of that is trying to happen to Brazil. So now we come back to this green area here: education, standardization, all of that kind of stuff. What is going to happen here? Skills, and let's start with skills and capacity building, which is important. First thing is formal education for security turns out to be not enough. One needs also non-traditional stuff. And one of the areas that is going to happen is to take much more look into professional training for non-academic people. The other thing is to take a closer look into virtual education, and we come back to virtual education later again. What would be on an online course system to be put in security? That is what the people are thinking about at the moment, and this is even a question of governance, as you will see. For the moment, you can assume that the first outcomes, the project has started on 1st of February, is to say, hey, the biggest area problem is not so much the security education in itself, it is the security education with regard to the specific application fields. So MOOC education is needed in a way that is combined with what is actually the cybersecurity issue for a smart city. What is the cybersecurity issue of a maritime transport infrastructure and the rest. That is one of the first pre-results that you can see. And the other thing is cyber ranges, and that may be of interest because cyber ranges are basically exercise areas that are federated and people are working together as a platform for education and training. And actually you will also see it here as an infrastructure for training and for testing. So these kind of collaborations of kind of mixture between labs and test houses and trial areas, that needs to be, the idea is to have that in a much more federated combined infrastructure all over Europe, and maybe also with other partners if they're interested. So that is happening in this work package 6 and 7 cyber ranges at the moment are expensive if you want to do them on their own. And one of the goals, or let's say one of the claims of CyberSec for Europe compared to other ones, is actually it's going to work with open tools and infrastructures. There are some of the fellow projects that are more on the military side and say we also do cyber ranges, we sort of do all of these exchange, but only when you can fulfill a military or secret qualification of confidential and higher. Otherwise, we cannot work with you because we are too secret, we are too important. The aim of CyberSec for Europe is we want to be here for the small and medium enterprises and for the ones that need these open infrastructures and do it with open source. So that's the specific area here. Certification is also in here. And that's an interesting political statement. It came pretty undertoned, but what you can say, it's now the statement of the European Union through this and actually also through the development of ENISA. ENISA is a European Network and Information Security Agency that exists now since 2004, 15 years. When ENISA was founded 15 years ago, the question was, should ENISA do certification of products and make sure that with certification consumers and users can see how secure products are, or can it be done by the market in itself? And 15 years ago, the market forces and the political forces said we don't need certification on a European level, the market can do it by itself. And after 15 years now, two things have happened. The European Union has changed the law for ENISA and will give it much more powers with regard to certification. Maybe some of the other powers have to go away. We come back later for that. And so there will be much more certification of products with regard to their security, which is not a trivial task, because when you make the security certificates too complex, people don't understand them. When you make them too simple, they can be misled. You need to find good institutions who can make these kind of testings. But anyway, the story is, after 15 years after saying we don't need this, now the story is to say we need it. And you can say this is a market failure, or it's a statement that indeed the market was not strong enough to do it on its own in the area of security. Which again, never anybody has said that so openly, but if you look what happened, this is exactly the statement. The market cannot do it on its own. And that is important also on a global basis, I would say, to consider. So then we're doing standardization, or we're involving with standardization. The project will not do standardization by itself. It will be involved with a number of standardization bodies, make sure that Europe is somehow represented. Lead contacts, basically the standardization people will be doing something in the area, and we're doing that with Cybernetica from Estonia under their leadership. They're doing that very nicely. So, you saw it got already quite political several times. Was there any question on one of these things? Now it's maybe get even more political, because we have this work package 2 about governance, design, and pilot tasks. And again, this has a story behind it in Europe, and the story again has to do also with ENISA, and has to do with money, and it has to do with power. And the story is the following. ENISA, this European agency set up in 2004, was designed in a way that it has a management board that makes decisions. And in each of these, in this management board, you have one representative per member country. So in Europe at the moment, that is 28. And maybe that changes in a few months or not. But anyway, at the moment, it's 28. And you have 3 votes from the European Commission. The budget is coming all from the European Commission. What has happened several times was that member state representatives, 28 of them, especially the big member states, have made decisions on what ENISA is doing that were not necessarily what the European Union as such considered to be useful, or what the ENISA personnel considered to be useful. One element is actually cryptography. I don't know how many of you have been working with cryptography maybe from time to time, or trying to encrypt something and keep it stored for a long time. Nobody yet, because it's a little bit, because it's so unhandy. But when you do that, and some people do that, one important question is, I'm encrypting something, and I want to keep it secret maybe for the next 10, 15 years because it's sensitive medical data, or I want to sign something with cryptography, and I want to make sure that nobody can forge the documents in the next 10, 15, or 20 years. Can anybody tell me whether the cryptography has the power to do that? And indeed, there was a European-wide research project called eCrypt, or eCrypt2, maybe some of you have heard about it, that has done every year an assessment of all of the cryptographic mechanisms that are popular, how strong are they, and can they be used, and how long do you need to make the keys, and all of that. And that was a very useful work by researchers, but it was on a kind of precarious situation because everyone, when the researchers had project money, they could do it. And the idea from ENISA was to say, hey, we want to do this on a continuous way every year by an official European body who gives money, and we can make sure that next year it will also happen again. That was the idea of ENISA and the European Union. Guess what happened? They did that once. Have you any idea what happened in the management board of ENISA with the 28 member state representatives coming and voting about next year's ENISA work program where this was in? What did happen? Anybody heard about it? Maybe you can guess already from what I say, but. So member states said, especially big ones said, no, we don't want ENISA to do this on a European-wide basis. This is a member state national security issue. Knowledge about cryptography and this kind of thing has to happen nationally. We don't want that there is any power developing in Europe about that one. Actually, small member states found that a bad idea, and quite a few experts also, but that was a decision. ENISA had to stop it. And you can find some arguments and can say, well, this is a national problem. You can say the opposite. What it clearly tells you, there is a governance problem here. One needs to find a solution that people agree on what is good, because we know the cyberspace is actually not ending at national borders. On the other side, there can be national sensitivity. So it's a big political problem which is coming with a small technical or big technical question. And this is just one of the examples why something needs to happen. And that is one of the reasons, probably, you will not hear that officially, so never had said that, but the new body that the European Union is setting up, if you look at the governance model for that body, you will find a voting structure in the management board with, at least in the proposals that the European Commission has made, and at the moment there is the member states and the Commission are fighting about that or discussing about that. Commission has said minimum 50% of the votes for European Union or European Commission, and other people only some money, some votes if they get money in, otherwise not. So a very different voting structure, very different distribution of power in this new body that they want to set up. And of course you can say it depends probably on which kind of questions are being dealt with. Which ones are really where you need to make sure that national culture and national sovereignty is not touched too much, and which ones are the ones where you need to say, hey, we need to really do this together. United States of America have now more than 200 years of doing something together, and in some areas it works nice, and in some maybe not so much. People talk about flyover states in the middle which are losing out, and the power is at the edge of the coast. So anyway, this is a not trivial problem. It comes back to cybersecurity, and it needs to be addressed. And that's what Work Package 2 to some degree is about. And we're trying to approach it with some ideas on how can this new body actually have its governance model for more detailed questions. If you look at the European, it's a CERN infrastructure, that is the one for nuclear power research, which is a big joint endeavor again, quite successful. Besides other things, they invented the World Wide Web there. Anyway, that has a model. Maybe we can take learn from something. We're trying to assess other practices. If you have strong opinions on this, actually, let me know, because we have in task partners in Trento at the moment interviewing people who have strong opinions about these kind of things, and to consider that. Anyway, we have to come up with some structure design, first elements and some later some, and to test it. And the first case actually where we say, hey, there is a conflict maybe, and that needs to be discussed, is actually this design of the course materials or the course topics, the curriculum for the online courses. Like what is in and what is out. That is something where it's pretty clear people have different opinions, you can have different reasons. Hopefully one can find a solution, so we're going to try design a governance model, then we'll take that case and try it out and see what comes out of it. So you can say it's a kind of political role play that is part happening here. But again, this is needed to get experience in the area of politics. So that was work package number 2. Number 1 is the administration part. Again, that's about distribution of the money, so I'm not talking about it. Then we have, of course, dissemination and outreach, quite a few of the typical activities that you have with other people, with working with a number of parties here that exist. EXO, by the way, is maybe of interest if you look into that as a public-private partnership that was the European Union Commission has triggered, and to have industry bundled in some voice on these kind of topics. And then there's a lot of collaboration with all kinds of parties, basically everybody that you can possibly imagine to be discuss stuff with them. What is the outlook and what may be of interest for you? Again, if you have anything on governance that you would like to share with people, please connect with me and I can connect you further. Anything that you would like to contribute about the experience with federated structures, again, Brazil is federated and in a federated structure is of interest. I can imagine that maybe the cyber range collaborations could be of interest for some of the people. Other stuff as you've interested. If you happen to be in Europe in the next few months, we hope that in Brussels in July we have an evening public panel, and that will hopefully then report a bit more on the experience about the negotiation of this new body that is happening in parallel, and the negotiations will go until end of June, even if the parliament is already voted in May. And then the first kind of event where all of these pilots will show something in November in Toulouse, if you happen to be there, maybe of interest. More stuff you will find, of course, on the website over time, and you can contact us if you have any further questions. But I hope it shows that security is very much a people thing, and it has a global connotation and global meaning, and I hope maybe I can take something home from Brazil and to learn fast. So, and you didn't have any questions or comments so far, but maybe you can have them now. Obrigado. I'm completely up with that. This is now.
Yeah, thanks a lot for the nice presentation. And just curiosity, in Brazil, we are now discussing a curriculum for undergrad degree in cybersecurity. So you probably have new undergrad courses just for cybersecurity issues. So it means what's being discussed now is should be the content of this kind of undergrad course, so just for curiosity. So another question is that for governance issues, how this new blockchain technology can help for stakeholders for sharing information, security information. I mean, of course, the mechanism itself is for building security and some trust in environment. But for the higher level governance, do you think this can bring some help in their process?
Thanks a lot. Well, maybe you're asking the wrong person, because I see lots of the blockchain movement as a bit of big hype. And I think the biggest thing, the biggest achievement of the blockchain movement is probably that many of the projects on public key infrastructures, on digital signatures, that were not implemented over the last years because there was no budget, because management didn't understand them and didn't want to pay for them. Now they're being implemented under the name of blockchain, because blockchain is a buzzword that makes managers pay money. And now with that money you can implement some of the security that you always needed to do anyways. That is maybe the biggest achievement that you have with blockchain. And coming closer to your question of this trust scenario, I think what we can learn from the blockchain approach is trying to find ways how to manage things in a more decentralized fashion when it comes to documentation. I mean, you know, the big claim to fame is that they say, hey, we don't need this central instance to document something. You have these decentralized register, and it works nicely. Well, that is a claim to fame. I don't know how many of you have been working with blockchain applications already. We have worked with a few partners, and there's 3 points. The one point is, when it gets really difficult and tricky, and because big amount of money or important decisions are at stake, all of these blockchain things, because they work like quorum systems. Some of you may remember from the distributed systems things, all of this quorum system. We all know all of these quorum systems, actually they have a tipping point where they start to fail, when the quorum is reached and still something is going wrong. And blockchain is no magic, it has exactly the same problem. And there lots of money is at stake. People can try to build up and to get the quorum with illegal means or with lots of investment into it. That is what you need to be careful about when you do documentation. The next point actually is we have GDPR in Europe. This is more for personal data. That may not be for other things, but for personal data, GDPR in the European point has said we need to have the right to delete personal information out of records. Blockchain is trying to do exactly the opposite. Never delete anything. That is a claim to fame of blockchain. And that from that point of view, whenever something like personal data are getting involved, blockchain gets difficult. So maybe I have one good news for you, and that is some of the blockchain applications that actually we have seen that are happening, and that is mainly of reducing effort. So there's a blockchain application happening in German railways, for example, or they're testing that. And they say because German railways now have been split up into profit centers, there is the train operators that are working for their own profit and the operators of the railway stations that are working for the operators. And whenever your train is in a railway station, you need to pay for that as a train operator. If your train stays there 5 minutes longer, you pay 5 minutes more. So they need to have a record taking. How long has a train stayed in the train station? And they say when we do this with sensors and when we do this with a distributed database with blockchain, and we can avoid that 2 different databases are being dealt with, that are being produced, and we can it's easier to have an automated record taking and automatic bill writing. And I asked them, well, what happens if you have a conflict? And they say, well, when we have a conflict, we have to sit down together anyway and negotiate about it. So the blockchain is not there to solve the conflict. The blockchain is for all of the cases that don't need security and for the cases where things are just going right. And there it is in gain of efficiency. So the added value can be a gain of efficiency. If I try to translate that lesson to our points here, maybe in some areas where it's about documenting things which are not so super dramatic, and when you have a chance to look into things and to negotiate things that are critical, maybe then it can help. But let's face it, a lot of things are about budget, and when money comes to the table, it gets critical and expensive. So I haven't found the application for blockchain that I would could willingly tell to you. If you have one for me, tell me.
That's why I'm asking. I can join in.
So you have to, if you.
In this opinion
I think you have to come.
Just as one criticism, but I'm loud enough, I think. Yeah. So one thing we shouldn't forget is that if we just take the darknet, for example, so most of the transactions for drugs, etc., 40% of the darknet has to do with blockchain. So it is a real problem. Second problem was mentioned here as a danger, the right to be forgotten, which is a European right, is no more possible. So if we are now thinking about CVs, etc., starting from school, to have it in a blockchain, then we have some problems. And speaking about system mobility, blockchain already needs as much energy as Ireland. Yeah, but we don't need that. That is the big, but Bitcoin is a blockchain. Yeah, but so, and now it was a negative thing. Positively, it was asking about nice applications. If we go, just an example, to the supply chain. Supply chain of fake medication, etc., etc. This is a real benefit. Like the Swiss delivery of the post, they have founded this kind of thing. So from the production to the customer, you can monitor everything, like, for example, temperature. For blood donations, for example, from the vein to the vein, it is possible to have a monitoring of the temperature so that the bandwidth of the temperature needed cannot be falsified. So there are some nice applications, but I also second him, and there's a very nice LaSiD paper where you have a nice systematic drawing where blockchain can be used. Most of the applications pretending to say we need blockchain don't need blockchain. But there are, of course, very nice applications where blockchain is of some benefit, and blockchain is also good for the user. So like every knife or whatever.
So if you have a security project and you don't get funding for it, try to put blockchain in. Well, actually, this would have worked a year ago. This would have worked. Meanwhile, the hype cycle is going down, so you have to wait for the next buzzwords that gets you money for your security project. Welcome.
Okay. Well, camera. Okay. So, okay. He's also a director. See. Well, this is one big issue. I think is privacy. That you talk about these cookies regulations now in Europe, and I think it's in Brazil now. Somehow this has impact. We have also some regulations. So all these applications now, they keep asking you if you want to allow cookies, etc. Well, one question is that you need privacy, but many applications for like monitoring things that going on in population or whatever groups of people. So many people claim they need this kind of information. So but when you have this information and somehow you lose privacy. So how do you think this can be conciliated somehow?
Okay, so this is an important question. Again, it's quite a bit about dialogue and about actually a decision that needs to happen in society. And have something. Let me tell you an example that is currently just coming from Germany. Our Home Office minister, who is basically the security minister for Germany, he says he would like to have more insight for the security services to look into the communication of teenagers below 14 years old, because some of them may be involved with radical parents or are working with Islamic State and are maybe preparing something, and children are getting ever mature, ever earlier. So saying only looking after people 14 years and older is not enough. And therefore they want to hack cryptographic devices also when they're in the hand of children. And this is now a discussion where people say, hey, below 14, you're not even, and you cannot even be put into jail because you're below the level that actually you can be punished for your child. And now the question is, do we want to use a security mechanism to solve an integration problem with some children? Actually, the level was put down to 16 and down to 14 already some years ago. But it is a discussion where people need to say, what kind of society and do we want to have? How do we want to deal with, and how do we want to deal with children? You can do some technical things. I mean, let's come back maybe to the digital twin of the car. I really found that one a very interesting example that Franz brought in. Think about, you have a digital twin for a car, and the question is actually who is managing the data for the digital twin of the car? Is it the manufacturer, and in lifetime with all of the real-time data? Or is it the person who has bought the car, or the rental agency? Or is it the driver? And now you kind of think about certain scenarios. Everybody knows young drivers, not you of course, but some others, they are not driving very well because they are too enthusiastic. They think they're the greatest drivers, Formula One racers, so they drive too fast. They create all kinds of trouble, expensive insurance quotes and so on. So should they maybe be looked into more by digital twins of cars? Actually, the insurance companies are now doing that. They say we can, when you have a digital twin of your car where we record what you're doing, then you can get a cheaper insurance and get a cheaper insurance then if we can record everything like that. And now the question is, do you want to have that as a family father, that your children's behavior is being recorded to the insurance company so that your insurance fee gets and gets lower. So it needs to be discussed. What you can do is, we can, for example, say we could try to have technical means that everything that is stored in the car is staying in the car unless the owner of the car or the driver of the car, and again, that is to be decided, says, okay, I'm willing to give these data away for whatever kind of purposes. But that would mean you wouldn't have it all in real time. You would have it, you can collect it in real time, and maybe even evaluate it, and people can look at their own data, but the decision who gets it later is to be done. So we have lots of examples here where indeed one needs to see what do you want to do. There is no magic rule. There is certain things that you can make, and where you can make things easier. You can say, for example, you can try to anonymize data. You can say, well, maybe for the traffic analysis, how much of a traffic jam is happening by people driving into Salvador every morning. You don't need to have all of the individual routes of Raimundo Macedo driving into the city. It's okay if you have all of the routes of all of the cars and you don't have the owner information. And then you may need to make some research. Can we make sure that all of the numbers of cars can be stored in a way that you cannot make a conclusion back to individual behavior? That is a research problem, and that is not trivial. Some people say, if you know 3 places where people are, like for example, and if you make location analysis, like where I live, and then I go to university working, or wherever I work, and I go maybe somewhere else. This is already, in many cases, in identifying a person individually already, because there are not so many people living at the same place where you live, working at the same place where you live, and maybe go to one other place where you have an interest to go, like your sports club or whatever your interest is. So it's not trivial to anonymize these data, and there's also research to be done here. One can do more than politicians do at the moment, especially than what is discussed in public, and it will not move away the fundamental decision on how much do we want to store and record the behavior of people for whatever kind of important goal in society: more security, more safety on the streets, more fair distribution of insurance money among payers. There's always a reason. People will always come with a reason, say, hey, we want more data, we want to survey things and look more detail into this because we can do something better. And the discussion is not, is it possible or not? The discussion is that kind of taking data worthwhile the effect for society that it claims to be? That is the decision that is to be made.
And now I'd like to invite Professor Yoko Murayama from Japan. And thank you very much for your being with us. And just let's go for the... Yes, thank you.
Good afternoon, everyone. It's almost, it's over 5 p.m. now. I'm from Tokyo. It's 5 a.m. So you understand how sleepy I am, okay? I try not to fall asleep. Okay, This time it's a great pleasure for me to present our work of IT for disaster management. I myself did my PhD in the internet at the University College London, in London, long time ago. Then I shifted to network security and then some psychological aspect of security, the sense of security, trust. And then 8 years ago, when I was working for a northern university in Japan, they have this big mega earthquake. And what happened was that there was no IT system to support disaster management. So I said, we computer scientists should look at more this part of research area. So that's how I started looking at IT for disaster management. So incidentally, this is 8 years ago in April. So mega earthquake happened and tsunami happened in March. So 1 month later, everything is destroyed yet. There is April is in North. It's cherry blossom season. So nature is very strong. Even many people died, but the tree keeps blooming. So it's a very sort of impressive scenery. Okay. So in Brazil, what happened? I looked up internet, what kind of disaster you had. I don't know if you know of it, but in January, the end of January, you had this is Salvador, but what happened is here, there was a dam rupture in Brumadinho, somewhere. And this said, this looks like a natural disaster, but actually I don't know. Because in 2015, at the same place, you had the same sort of a problem. So if they fix the problem at that time, probably it never happened. So some part of the disaster is not only natural, but man-made disaster as well. So the word disaster includes terror and everything man-made and natural. But in my country, every month we have a natural disaster, small or big. We have many earthquakes. We have we don't have a typhoon, just a strong flood. That made a disaster too. So it's very strange these days. And in Europe, in Austria, there was absolutely no disaster before, but nowadays climate changes. They have a flood or something like that. So we have to be, very aware everything would happen. So you have to be very prepared. Okay. So 80 years ago, what happened? It's Friday, so the end of the week, and it's 3 o'clock in the afternoon, and 11th March. 11th March, it's still in the north, very cold, like Scotland in Japan. And then the mega earthquake, like 9 magnitude. I don't know, how strong it is, but this is very strong. In Indonesia, they had earthquakes 3 times in 6 months last year. But then they had, the biggest one is 7.5 or something, but it's still very strong. So 9 is very strong. And that caused a big tsunami and people died. So I show you what happened in our office, in a research office. Iwate is secondary top of main island. It's very north. And I used to work somewhere here. So seaside were really hit by tsunami. And this research laboratory was here, okay? What happened? So this is what happened in March 11th. So nothing happens. Oops. It doesn't work. Oh, okay. I don't know. Okay. Here comes. And so tsunami is coming. So this is what happened in this research lab. So in a minute. So they destroyed everything. The ground floor, there are computers. It's gone, you know. The seawater came in. So all the memories lost. They lost the data and everything. And the papers are contaminated with water, and you practically lost everything in terms of data. Something is wrong. Okay. So what happened at office? The ceiling panel fell down and everything, and you know, it's still cold, so old-fashioned stove, the heater was needed. And the people, one of the members in this research lab came to our university to work, so she told me what happened, and real tsunami is more than one can imagine. And this kind of things, usually people just prepare, didn't work, really. So, what is important when you had a tsunami or something? This stick memory. All the data were destroyed except this one. There are 90% of data in this traditional USB stick memory were saved. What happened in Japan, industries prohibited their employees to have this because it caused information leakage. You know, in a stick memory, you know, people would put the customer's information or what are secret information and put it in a pocket and go away. So usually industry prohibited their employees to have this memory, but this memory saved almost all the data. So I don't know. So that happens. So outline of my talk, I usually take 1.5 hours of this, but I only have got 11 minutes. So I skipped most of them so that you enjoy. So I explained what happened and the findings, support requirements, and IT requirements, and the recovery watcher. Well, this is one of the systems we created, and you know, this sort of thing. So, damage caused by disaster, that disaster was this. This is the top of the main island. And only the coast part of 3 prefectures had a major damage. Fukushima is most famous due to this nuclear power plant, yes? Because they have to evacuate the places. They can never go back. So it's a worst part. And still they have been contaminated, so it's really bad. So Tohoku region, so those regions, this number of deaths is 15,000, and missing almost 3,000, something like that. And Iwate, where I used to live, is one third of the number of deaths and the missing, this sort of thing. So it's quite a big disaster. However, in Iwate, you know, they have this sort of disaster every 30 or 40 years. It's incredible. And they repeated the same number of deaths and all that. Why is that? Local wisdom. Tendenko means you scatter away. You shouldn't take care of your family. You just go away. Go to the higher places. But actually what happened was people went back to their home to check their parents, to check their children and all that, and they died. So if you have a tsunami, you just have to run by yourself, trusting your family members will evacuate in the same way. So this wisdom didn't work. Why is that? Because they have 30 years or 40 years difference. That means information passing, knowledge passing didn't happen generation by generation. That is most important part of this tsunami this time. So what happened? No, you have you have a smartphone. So you always, telephone your friends, your family. So you think you can check for the safety of your family member in this case. However, this works based on the electricity power. If there is no power, this is nothing. It's no use. And this happens. There is no communication line available. Wire telephone line is no wireless. Some temporary base station will provide it. So some part, it did work. But limited telephone access. There was actually no limited packet switches access. That means you could have used the internet. Why is that? Number of the customers were very small. So they can use. But if everyone else use it, maybe they have only limited access as well. And this is most important, electricity. There is no electricity. So as long as it has electricity, it works. However, if there is no electricity anymore, there is no battery or anything, everything has gone. So your information, your IT devices are working based on the electricity. If there is no electricity, you can't do really anything. You can't. So findings, what is needed was an IT support for supporters because there is no information support system for supporters like a fireman or civil servants. So it was needed. For firstly, we needed safety information and the information on sufferers, family shelter, and shelter management and the good distribution. Never be well planned because some shelter needs water. They are provided with blankets. Where another shelter, which needs a blanket with water, they are provided with water. So this sort of coordination was really need a communication, the good communication systems. And medical information, disaster week, this sort of information should be collected from each shelter. And there are a lot of donations from different countries or something like that. And there should be a traceability if you donate. But if you see how your money were used for victims should be traceable, that is very important. But this happens actually 8 years ago using a wish list of Amazon and all that. And there was an IT system called the Sahana, which was created 2004 or something by the programmer in Sri Lanka, which created Sahana. It was available for use even when we had this disaster 8 years ago. However, the system was explained in all English. So firstly, we have to translate all the comments and display messages into Japanese. The users of Sahana, this sort of system, are civil servants in a local government. They do seldom speak, understand English. They have to be localized into Japanese. So that took a long time. And for those ordinary people who are supporters, only know the well-known interface like Excel, they can use it. But they don't know any other things. And this disaster management system is a killer application for cloud computing because the information should be kept for long. So I think if they keep the data locally, anything happens, they will lose the data again. So this sort of things we found. And I only have 3.5 minutes, so I don't know how I can finish, but findings are what is needed for disaster management. You really need the speed. You need to solve anything in a minute. Even the solution is not good. You really need to do something. And rhythm, I call it. If you need something to solve, you keep communicating various kind of people, then solution will be coming up. And trust, we need the trust between people because in a disaster management, different people working on the same issue. And they have different perspectives. So there are a lot of disagreements, and it will delay the disaster management work. Okay. So support for Iwate. Iwate is as big as 15,000 square meters, and that is not really, but almost same as Sojip. Yes, kind of, so this big. So we are working in a university here, and the local government, main capital of the state was here. So people would go to help because there is no public transport available at the moment. So at that time, so we just moved to there by car. From here to here, it takes 3 hours. So if you go there and doing something 2 hours and come back, that is almost a day. So it's very tiring. So technical support required was people search for safety information was needed, visualization of lifetime, so 1.5 minutes. So, you know, a lot of things. And the network for information infrastructure, shelter information was needed, and volunteer support were needed. This sort of things, we need IT support. So actually we did. We have a lot of donation of PCs and the printers and cameras from the industry in Tokyo, yes? So that happens, so they send us. So we just provided those systems, like internet working in PCs and this yellow part of shelters in it. Because in each shelter, there was a medical group. So doctors needed this sort of communication system to talk to the doctors here. There is a big medical school. So, you know, using the internet, the doctors speak to each other to solve the many issues. So support organization, we worked as a coordinator. And solutions were provided from industry in Tokyo or any other, you know, organizations. And the needs and the seeds, we didn't hear from victims directly, but we heard from volunteer center and the local government people. So coordination is very important. So this is something like, I only have, well, it's finished. Okay. So I try to finish my talk. Okay. Next time I will talk. But this student is from Tokyo. This university, Keio University, has a very good decision. Why is that? April is the beginning of the academic term. So they are supposed to be in the school, but the head of the department decided, oh, our university, our department will start in May. So in April, you just go to NOS to help out the people. So we have a lot of students from that university to help out. So they are cabling of one of the shelter which were used by school, as a school, yes? So this sort of temporary situation, you just cable very loosely, because in 3 months' time, you have to take away. So this sort of cabling is disaster kind of treatment, okay? So this I don't speak this time, but the disaster communication is needed. Risk communication, you talk about the future risk, but disaster communication is something happened now, so you need to do now. So that is the disaster communication. Then we need the ICT support for disaster communications. So we have a lot of things, but I think, so this is a disaster management cycle. So it's just 1 week or 2 weeks, and then this from here to here, it's 3 months. And the shelter will be closed, and they move it to temporary housing, and it takes a year or 2 years until you have a next disaster. Okay? So as in terms of shelter, it's changing. In the beginning, I don't know what happens here if you have a disaster now. What kind of place you set up a shelter? But in Japan, usually a big sort of building, gymnasium of the school, and they put people together. So there is no privacy, no security, anything. So this is not so nice, you see? So after 3 months, it's a temporary housing. So you have a small apartment, but it's temporary, so you can't hear the noise next door. So it's not so nice. And after probably a year or 2, you move to a final reconstruction house. So you should be more happier here. What happened? Here, you have more alcoholic people or commit suicide. Why is that? Until here, because the living situation is not so nice, so people try to get together in one group, you know, in a common room or something, so talk to each other. There is a communication between residents. But here, conditionally they are happy, so they don't come out of their own room. So they have a mental problem that losing a family, and they feel very lonely, and they commit suicide. So that is a problem we need to solve in future. So we just created a recovery watcher to keep watching, and put the camera and see what happens. So we just created, and now there is a barrier-free program as well. So I think this accessibility problem should be considered in a disaster too, because this sort of inclusive issue is very important at disaster. You have to help out the people all together. So we actually created various kind of disaster management systems, and we found they are all usable for barrier-free somehow. So we are creating this time. Anyway, this is the end of my talk. And lastly, I introduce the IFIP Domain Committee on Disaster Risk Reduction. I'm a chair, and we have many people to support. And we have a keyword of resilience, humanitarian, and sustainability. You heard this from Gabriel's this SDGs. Actually, disaster is directed by, they said SDG 11, but it's not true. Disaster is a human right problem because you can't lead the normal, healthy life by yourself. It was destroyed. So in terms of that, it's SDG number 2, 1, 2, 3, 4, everything will be included for disasters. So that is what happens. So we will have this conference in next. Oh. Oh. Anyway, it's finished. So we will have. Okay. Okay. Well, okay. We will have a conference in 2 weeks' time, a workshop. Okay. That's my university, current university. I don't know. Why? It's okay. This? So future event. We have this workshop at the USIS, at the ITU, the United Nations event. And in October, we will have this IT in disaster risk reduction conference in Kiev, Ukraine. So, you know, if you have any paper to submit, you are welcome to submit. There is absolutely no deadline because we produce post-conference proceedings. Okay? Thank you very much.
Any question? Okay, thank you a lot. Thanks a lot. I'd like to invite Professor Ji-In Kim from Korea for the next presentation.
Okay, good afternoon. My name is Ji-In Kim from Korea. This is another sleepy guy because I'm living in very close to Japan. Okay, the topic of my talk is user experience. I'm going to give you a very introductory talk about user experience. People say this concept, user experience, started 19th century and early 20th century. At that time, workers built machines or assembled cars in a factory, and then some workers preferred to use specific tools like screwdrivers or hammers. The other workers prefers another type of tools. Of course, there are some technical issues, but there are some other things we should think about. So they started think about the other thing that is called user experiences. And then in 1990s, when there are many websites available and also many computers, many softwares available, we found that some people like website A, the other guys like website B, even though they provide similar functions and performance. Why is that? Okay, so people started using these user experience terms once again, try to find the reason and why that happens and how we can build a better or more, what should I say, depend on people based on their preference or things like that, try to make more likable or more usable website and applications. Okay. Is it working now? Okay. If we follow the Wikipedia, they define UX as a person's emotions and attitude about using particular product or system or service. So they thought emotions and attitude plays very important role. Okay, of course, if you are building or developing a product or service, their functionality and performance, the optimization kind of things are very important. But also there's another issue we have to think about. That's user experience. Okay, and the other researchers, especially this guy Donald Norman is very big figure in this area of user experience. He emphasized not only the emotions and attitude about the service and product, he also said we should think about the image of company or brand images kind of things. Okay? So let me give you the definitions, a standard definition of ISO. They define user experience as person's perception and responses that result from a use or anticipated use of product, system, or service. Okay? According to their definition, user experience include emotion, beliefs, preferences, perceptions, physical and psychological responses, and many, many things. Okay? So, as you can imagine, this is a very difficult term and when we think about these issues. So, as you can see here in this diagram, user experience covers many terms. Not only the user interface, it covers platform, functionality, information architecture, content strategy, usability and accessibility, etc. Okay? So it seems like user interface is only part of it. So when we think about a user experience, I think we should, we should think about functionality, performance, and also user experience. So let me give you one of the messages. If you want to give a good or better user experience, first thing we have to know is we should know about your users. Okay? As you can see, this is a thing you can find in the public toilet for men. Okay? This is very unusable water. Please change this, okay? Like I said, you should know more about your users when you build some product or service, okay? When you do this, I would like to quote my mother saying that boys never grow up and they never listen, okay? My wife also agreed her statement. As you can see here, you can also find this kind of messages, okay? Boys never grow up, they never listen, okay? So even though you put this kind of messages in front of this device, they never listen, okay? If you go to China, you can find these messages. it says, small step forward, one step civilization. It should be, this is a big, you should say big step civilization, okay? Whatever civilization you are, boys don't listen. So look at this. This is the just ordinary device, but if you look at this, you can find the fly here. Okay? The designer of this device understands the boy's behavior. Okay? Boys like shooting games. Okay? So once you put this thing, you don't have to mention civilization anymore. Okay. And the other message I like to give you is when you, even though you understand your user's characteristic, behavior, etc., okay, when you develop a product or service, there are many things you have to consider, okay? Business issues and companies and developers, etc. Second message I like to give you is consider the user first. It's not easy, but that's the message we want to give you when we talk about user experience. This is the parking lot. You can find many places. Okay. This is the just garden in front of our building in our university. The problem is here, when you park your car, you have to go around to get into your office. Okay? In this garden, there is a student restaurant. You have to go this way to get to a student restaurant. So, you see, this part, there's no grasses anymore. So we can have two solutions. The first one, you change the design and make a new path for your customer or user. Or you can block it. Okay? I would say this is South Koreans thinking, this is North Koreans thinking. Thank you. So when we talk about user experience, there are good examples. We always talk about Apple, okay? This is quite old picture, but this thing happens in many companies, like Samsung or Apple, many companies. They use faster CPU, okay? But difference here is that they choose faster CPU, not because the semiconductor technology expand or they can have a faster technology, but their motivation is their user use multimedia content, service, and applications a lot. The traditional device getting slower and slower in order to satisfy their customers' requirement, they use a faster CPU. Okay, that's very different approach. So let me give you an example of good user experience by telling stories about Steve Jobs. I think all of you understand or heard about stories behind Apple and Steve Jobs. Okay, as you know, he founded Apple company and successful, even though he put a new graphical user interface almost for the first time in personal computers, he failed many products. He expelled from his own company in 1985. And then after 12 years, he returned. As you can see, within a year, he developed a new computer, okay? Without having a new design team or new development team, he had the old team and developed a new computer. It was a called iMac, which was sensational. I think some of you may recall old days. You can remember what a computer looked like at that time. It's an IBM computer. Actually, it is built using steel, very heavy, and it needs extra monitor to use, okay? At that time, Steve Jobs' iMac looks like this, quite different, okay? What are the main difference between this one and this one? What? Screen, yes, yes. One thing is they put all in the one body. Second one is color. At that time they also use mouse, but difference is color and this put so-called all-in-one thing. So people say, why this was so sensational? The two things. Before, at that time, computer was mainly used in office. They used for working, okay, editing documents and compute some numbers for your company, your organization. But time changes. Steve Jobs noticed that it's time for personal computing. It means you put your computer at home. What would you do with your computers at home? Playing games, okay? Listen to music, okay? Watch movies. So, as you can see here, Steve Jobs was put on a Time magazine. The statement here is, iMac is an all-in-one hub for music, pictures, and movies. Okay, so this is the one thing, one of the first product Steve Jobs made after returning to his own company. At that time, he understood that there's a new trend for new generation users. Okay, they want to put their computer in their desk at home and watch TV or playing games, listen to music, etc., etc. This is not for your work. This is for your fun. Okay, that's the one design innovation he got at that time. And second successful item is iPod. iPod is MP3 player. Okay, I remember because a friend of mine worked for a Samsung company. He developed MP3 players before iPod. Okay, but his product failed because of this sensational iPod. Okay, the thing he noticed was at that time everybody download MP3 music from the dark side of the industry. Okay, they copied it for free. That makes customer happy in the beginning, but content providers was not happy. So there was conflict between content providers and consumers. So if you remember, Steve Jobs persuaded content providers, and build this sort of iTunes music store, and he provide consumers with music at a reasonable price. Okay, so we called he create ecosystem of multimedia content industry. So this product is possible because Steve Jobs understand people's need, and also content provide needs, what they need and what are necessary. Okay. So here's another picture. He put in worldwide magazine Newsweek. Okay. Third product is iPhone. I guess everybody understand how successful it was. One data shows that all other products sales cannot exceed iPhone sales. It was really sensational. Then what is the reason of its success? iPhone was not the first smartphone, and at that time its function and performance is far below than existing smartphones. At that time, BlackBerry is #1 in the market. Okay, but the first one is very unsuccessful. But in third one and fourth one, iPhone becomes sensational. What's the difference? People say before, this is the phone, which is smart. It means telephone, you can use email, and you can check a stock price, you can send some sort of document editing kind of things, okay? However, iPhone is totally changed the concept of smartphone. This is the computer. iPhone is the first handheld computers, okay? So computer needs new software, okay? So App Store was created, it was introduced, and it opens a new market, a new field, a new industry, okay? So as you can see and know, Steve Jobs and Apple understand users very well, and they provide solutions for new generations, new requirements, okay? This is a designed for satisfying new requirements of new generation users, is iMac computer, I would say. And then he created a new ecosystem for multimedia content industry and introduced first handheld computers, okay? This is what we call a user-centered design and development. So when we talk about a UX, the first message is we should understand users and design and develop by putting our users at the center, okay? That's the two messages we should emphasize here. Okay, there are too many pictures, but if you can see it carefully, what they say is, this is the picture that the customer explained it, okay? And then what really needed is this one, okay? But this is how engineer designed it, okay? This is how customer was built, okay? This is how the help desk supported it. As you can see here, there are big difference between what the user really needs and what engineer design, what actually they get, actually paid, okay? Okay, then question is, how can we find what users really need, okay? So there are a number of strategy. Like I said before, first you understand your users, okay? There are two types of users, they say. One is expert users, who knows everything about the product. Okay? He knows MP3 players, he knows computers, etc., etc. Okay? They always criticize your product. Okay? They always give you the negative side, negative points. And they always need more and more and more. Okay? They are very good and smart. But problem is they are only 1 or 2% of customers. They don't buy your product. Okay? The people who buy your product is mainstreamers. They are more than 90%. So you should understand what the characteristics of mainstream users, what they want, what they really need. Okay? You can ask something to expert, but do not trust them too much. Okay? So that's the difference between expert and mainstreamers. Okay? Expert wants to precise control, perfect result, exact match, etc., etc. But mainstreamers, or most of users, just want to make it easy, reliable, good match is enough. Okay? So you have to think about this very carefully. So first thing you have to know is user, and next one is what their requirements are. So there are a number of statements describing requirement, statement defining what the site, website, or application needs to do. It provides insight to overall needs, represents and combines needs provided by different stakeholders, give the directions for designs, etc., etc. Okay? I repeat, in order to get clear and solid requirement, you understand current state, needs and ideas, and merge them into requirement. And you don't need to satisfy all the requirements because you have a limited resources and limited time. So you have to prioritize when you satisfy your requirement. Okay? Okay, let me skip. We don't have much time. It's almost 6 o'clock, right? Okay, I know your requirement. Okay, there are a number of techniques. For example, if you buy something from your online market, okay, you want to tracking your order, okay? There are a number of issues you have to think about. In the area of order tracking, orders can be tracked by entering a tracking code online so that user can find the state of your delivery, your product delivery, okay? Or if you have enough money and enough resources, you can put a GPS service into your online market, okay? Or you can have some services that gives your user shows all past orders made in last 365 days, etc., etc. Okay, these kind of requirements are possible, but like I said before, you have to think about many issues and put it in the list with priority. Okay. Okay, let me skip this one. So generate requirement, listen to user, and also you have to check your business need and prioritize them. Okay, finally, once you know what they need or what they want to do, and then second step is you understand how the users do. Okay, so Donald Norman created model of interaction between user and computer. He put it into 7 stages. This model explains user's view of the interface. For example, suppose you want to know more about Brexit, okay? Then that's your goal. You may use Google, or you may watch TV, whatever you want, okay? Then there is a 7 steps. You establish your goal, formulate intention. Maybe I want to Googling this, and specify the action. You actually type it and execute, see the result, and interpret whether the result shows answer. If you are satisfied, then you stop. Otherwise, you repeat this thing again, okay? So once you set up and you want to execute this thing and let system work for you, okay? And then you want to evaluate the result, whether your goal is satisfied or not, okay? You do this kind of evaluation and execution loop, okay? Set up goal, etc., etc., okay? So why is this model is important? Because with this model, we can say which system is harder to use. You can compare usability of 2 or more systems. Okay, he defines 2 issues. One is gulf of execution. It means user's formulation of action is not equal to actions allowed by the system. Second one is user expectation of change in system state is not equal to presentation of this. It means this gulf of execution say user want to run some command, but that command or that action is not allowed by the system. So user feels some problem when execute something, okay? If you make it easy, okay, you allow this kind of actions or command, what user intended to perform, you must allow that, and then your system becomes easier, okay? And second issue is remove this gulf of evaluation. Means operate, make it operate as the users expect to behave your system, okay? Then if you check these 2 things, you can determine or you can evaluate whether your system is harder to use or easier to use, okay? That's what the Norman's model says, why it's useful. So let me conclude my talk. Although this is very hasty, but this is almost 6:10, so it's time to finish. Once again, user experience and user-centered design becomes very important. Not only the website or applications or services or product. Many people talking about IoT and wearable computing kind of things. If it comes to this product and services, we don't have monitor, we don't have keyboard, so there should be some natural and easy way to ask or command our device, which is hidden in our environment. So that's why this UX or user-centered design become more important. So I repeat, you have to understand your users, and also you focus your users and stand your users' side when you develop and design your product and system. Okay? Thank you for your attention.